Okay, so you're probably all excited to learn this special rule when solving linear inequalities. So let's go back to solving equations for a minute. If I have 2x equals 10, I'm allowed to divide both sides by 2, and I get x equals 5. No problem. If I have negative 3x equals 27, I'm allowed to divide both sides by negative 3, and I get x equals negative 9. No problem. If I have 2x is greater than 10, I can divide both sides by 2, and I get x is greater than 5. No problem. But if I have negative 3x is greater than 27, and I divide both sides by negative 3, now here comes the rule, the special rule, I get x is less than negative 9. Notice that this inequality changed the other direction. Nothing else changed. I still get x on the left and I get negative 9 on the right. It's just that inequality changes. Now why is it? The rule is if you multiply or divide by a negative number, you have to switch the inequality. Now I'll write that up in a minute. I'll write it now. If you multiply or divide by a negative number, then you have to switch the inequality the other direction. So I think of it like the possession arrow. So it was pointing to the right in our example, and now it's pointing to the left when we get the answer. Okay. Now, a lot of times students are like, well, why does that? Why would that happen? Okay. If you have 5 is less than 10, that's true, right? And you could multiply by 2 on both sides. Well, multiply by 2 on both sides, and you'd have 10 is less than 20. That's true. But if you have 5 is less than 10, and you multiply by a negative 2 on both sides, you get negative 10 is less than negative 20, but that's not true. See, negative 10 isn't less than negative 20. Negative 10 is greater than. So that doesn't work. You have to make it negative 10 is greater than negative 20. So you have to switch the inequality. When do you switch the inequality? Only if you multiply or divide by a negative number. Okay, that's the special rule. Nobody's going to tell you, there's no little person to come and say, hey, you divided by a negative number, switch the inequality. You have to remember on your own. Okay, so 3x is less than 6. All right, I want to solve for x. I divide both sides by 3. I get x is less than 2. No problem. I'm just dividing by a positive 3, so everything's good. I can graph it. Here's 0, here's 2. We're talking about the numbers less than 2. That interval is going to go from negative infinity to 2 with a parenthesis. Okay. Now b. Well, I want to solve for x, so I'm going to add 1 to both sides. Negative 2x is greater than or equal to 6. Now I'm going to divide by negative 2. Okay, now that should hopefully your ears perked up or something. That says this is the situation. I'm dividing by a negative number, so I get x is less than or equal to negative 3. I can graph it on a number line. I keep graphing them because habit, I think. So less than or equal to is going to be bracket this way. So negative infinity to negative 3 with a square bracket. That would be the interval. All right, we've got one more. So I have 5 minus x is greater than 10. I'm going to subtract 5 from both sides. That gives me negative x is greater than 5. Now you might be saying, wait a minute, you used a negative 5. Well, I'm subtracting. I didn't divide by a negative 5. Okay, I didn't multiply by a negative 5. I'm just subtracting 5. So I'm okay. Now I have to divide by a negative 1 though. Okay, now that's the rule. X is less than negative 5. Now in my 3 examples, they always wound up being less than, but that's not always true. I don't know why that happened. Sometimes it just does. Okay, x is less than negative 5. You're talking about then if here's 0 and here's negative 5. We're talking about all the numbers less than negative 5 this way, negative infinity to negative 5 with a parenthesis. You could have them be greater than, we just didn't happen to have an example of that. All right.